What's going on, guys? Let's do this problem right here. Here this question is asking for heat transfer in 1 hour, but in order to do this one, first of all we have to find the heat transfer rate. In a convection process, to calculate heat transfer rate we have to use this equation, that is Q dot is equivalent to HA delta T, and here delta T is surface temperature minus surrounding temperature, and for H for a vertical wall. So first of all, let's describe this question first. We have vertical wall right here, and in surrounding we have air, right? So the question is asking what will be the heat transfer from this wall to the air, because the temperature is always going to transfer from hot to cold, so it's going to go from wall to air. So this process is convection. That's what we are trying to find, the heat transfer rate during this process. Now to find this one, we need these values. We have the area that's provided. Delta T is going to be simply surface minus surrounding, but convection we have to use a different technique. But for a vertical wall, the convection, this heat transfer coefficient can be calculated using this formula. H is equivalent to 1.77 times delta T power 1 over 4. So this is the generic equation for a vertical wall. Now the units for this heat transfer coefficient is going to be joules per second meter square degree Celsius. Now let's go ahead and plug this one into this equation to calculate this one. Now let's plug this one right here. This is going to be 1.77. I can add this, we already have a delta T, and in this heat transfer coefficient equation we have a delta T power 1 over 4. So this is 1, this is power 1 over 4. If you add them together, 1 plus 1 over 4, that's going to give you 5 over 4, right? So we can write delta T power 5 over 4, and we are going to have area right here. Now here the thing is, since we have both sides, area is 27 meters square, since you have two sides right here, 20 degrees Celsius this side, 20 degrees Celsius this side, so we have to multiply this one by 2 because we have heat transfer both sides. So we have to multiply 1.77 then 20 meters square times 2, right? 2. Let's get rid of this unit first, because we have this heat transfer coefficient unit and we are combining this delta T, so that will get complicated. As long as we keep the SI units, we are fine. Now here we have this 20 meters square. Since we have heat transfer both sides, we have to multiply this one by 2. And the temperature difference is going to be 100 minus 20, because surface minus surrounding, that's going to be 100 minus 20. So this is going to be just 80. 80 power 5 over 4. And if you calculate this value, you should get 16,940 joules per second. Now the question is, what is the Q? That is heat transfer in 1 hour, after 1 hour. This is heat transfer rate. This is heat transfer rate. To calculate heat transfer, we just multiply this Q dot by time. So that's going to give us heat transfer. Now Q dot is this value. This is 16,940 joules per second. Since this is in joules per second, we had to convert this hour into second, and we know that in 1 hour we have 3,600 seconds, so we can multiply this one by 3,600 seconds to convert this one into joule. Now if you multiply them together, that's gonna give you 16,000. So let's write this one in terms of scientific units, because this is going to be a huge number if you calculate them. So this is going to be 6.1 times 10 to the power of 7 joule if you calculate that, and that's going to be our final answer. I hope you guys find this video helpful. See you next time.